So today we have GFG weekly contest. So the contest has been, so 1 hour of the contest has been passed. So again, so I am trying the question in last half hour. So let's see what I can do in the problem statement we have. So this is the first problem we have. So given you are given an array A consisting of n positive integer, in one operation you can choose any index I such that AI is even, then you can assign AI is equal to AI by 2. Your task is to make total sum of the array even using minimum number of operation, or return -1 if it is not possible. Acha, your task is to find so basically we have given an array and we can do an operation that we can choose any AI and make it, we can choose any index I such that AI is even, and we can convert that AI into AI by 2. So we want to find basically the minimum number of operation required so that we can make the sum of the array even. So if the sum of the array is, let's say, sum, and it's already is a even number, then we don't need to do any operation. So int I equal to 0, I less than n, and I plus plus. So that's it. So first find the sum of the array. So it's basically a of I, sum plus equal to a of I. If sum modulo 2 is equal to 0, that means sum of the array is already even, so return 0 in that case. So the number of operation you will require to convert the sum of the array into even will be 0 because it's already even. Now if the case is that it is odd, so if the case that it is odd, it is going to be the odd, then what we can do in that case? In that case I have to pick an even integer and make it odd. So I have to pick an even integer in the array and make it odd with minimum number of operation as much as possible. So how we can do that? So basically we have to iterate. Let's say minimum number of operation we want to store in a integer, and I am going to assign the initial value to that integer is nothing but int max. Let's say I am assigning it the int max. So I want to store minimum number of operation to convert an even number present in the given array into an odd number. So that is I am going to store in the answer. So let's iterate over the array. Int I equal to 0, I less than nums dot size not I less than n, and I plus plus, and check if capital A of I modulo 2 is equal to 0. That means you want to convert it in an odd number. So basically we want to find the minimum operation so that it can be converted in an odd number. So we can divide the number till it becomes an odd, until it becomes an odd. So we will divide until it becomes an odd. So once it becomes odd, we will stop dividing that number. So, and it will take a complexity of log n, because I was dividing every time I am dividing by 2. So the complexity in worst case to make it an odd will be going to be log a of I. So it's an optimal solution, we can say that. So if while a of I modulo 2 is not equal to is jab tak till the number is going to be even, we are going to divide that number. So a I by equal to 2, and let's increment a count variable, count plus plus. So basically as much as the number of operation you will require to convert this AI into an odd number, the count is going to store that value, because it is going to increment that much number of times you are going to operate on AI. So our count is going to store the minimum number of operation you will require so that AI get converted into an odd number. So after that I want to minimize the value of answer with this count variable so that it can store the minimum operation required so that you can convert an even number into an odd number. So that's it. So answer is equal to minimum of answer comma count. So after doing these things, you can simply return this answer. It is going to store the minimum number of operation you will require so that you can convert the sum of the given array using this operation and or an even sum. Okay, so let's submit it. I think it should work. so it's not working. Your code output is I equal to 0, I less than ai modulo 2 is equal to 0, ai by equal to 0. It is given return 0. Okay, is equal to 0, while ai modulo 2 is equal to 0. So 1 2 3 4 5. So in some cases you can't convert, in some cases you can't change the sum to an even sum. So in that case answer should be greater than 189, then that means you can't convert the given array into an even sum. So in that case you have to return -1. That's what I was forgetting, that's why it was giving error, because I was thinking that it will always give it, there will be always a possible answer. So now it will work. So we can see. So let's move to the next problem statement we have. So this is the explosive, the problem name is explosive. So let's read the problem statement. Geek is fond of explosives. So geek is a person, he is fond of explosive. He has lined up a row of n boxes containing explosive in his gardens. The boxes of k different colors. The ith box is of color I. So he has n boxes containing explosive in the carton. So he has lined up a row of n boxes. So he basically put the boxes in the row containing explosive in his garden. Okay, so these boxes contains basically an explosive in his garden. So every box consists of some explosive. The boxes are of k different colors. So each so boxes are of k different colors. So the total number of colors in which the boxes are colored is basically k. So the ith box is of call I. So you have given also an array call. So call of I represents what is the color of the ith box. So if 3 or more boxes of similar color occur together, all of them will explode without affecting their neighboring boxes which are not of the same color. So if 3 or more boxes of the similar color occur together, all of them will explode without affecting their neighbor boxes which are not of the same color. So basically it is given in the question that whenever 3 consecutive boxes having same color, they will explode without affecting their neighbor. Okay, occur together, all of them will explode without affecting their neighbor boxes which are not of the same color. Acha, more than 3 or more than, so basically some number of consecutive boxes having same color and that number is going to be greater than 3. In that case the boxes will got exploded. So it is given in the question. In initial arrangement of the boxes, no 3 boxes of the same color will occur together. So in the initial situation of the boxes, no 3 boxes of the same color will occur together. Okay, so the initial situation of the given boxes is that no 3 consecutive boxes has the same color. So geek has an extra box with him of color C. So geek has an extra box of color C. He can insert that box between any 2 boxes in the row to set off the explosion. So help geek to find the maximum number of boxes he can explode. So basically he has an box, he has an extra box whose color is C. He can insert that box between any 2 boxes he has given in the raw form, and after putting that box between 2 boxes, the explosion can start. So basically you have to find that maximum number of boxes can explode. So this is the color of the extra boxes you have. This is going to be the total number of distinct color you have, k, and this is your number of boxes we have. So basically if you are going to put this C color of boxes between any of the 2 boxes given in the column, so what is going to be the maximum number of exploded boxes? So basically you want to maximize the explosion of boxes after inserting the, what you can say, after inserting this new colored boxes somewhere in the box array. Find the maximum number of boxes can be exploded. So basically we want to find the maximum number of boxes which can be exploded. Okay, very good. So how can we go for it? So you can see, if you are going to insert 3rd and 4th box, if you are going to insert this C2 color between these two boxes, it is going to explode. It is going to explode. So that's it. So what will happen after exploding the boxes of same color 2? These 4 boxes of color 1 will get attached and it will also explode. So how we can approach this question? So we have the whiteboard. If we can talk about, let's say no 3 boxes has the same color. So the cases is like that. You have the boxes like that. You have some pieces of boxes like this, same color. It will either contain 2 boxes of same color or 1 boxes. So what will happen? Consecutive 2 same color will happen. Consecutive 3 same color is never going to happen. So this is the case we have. So like this you have the color of the boxes. Now you want to insert some explosive anywhere in the given condition. So basically, if your color of your explosive is C, so basically you want to put the color somewhere in the array so that it's one of side it is going to share with a boxes of same color C. Very good. If there is no 2 boxes of same color adjacent to, no C color of boxes are adjacent to each other, then you can't explode a single box. So that's what I am saying. If there is, let's say there is no 2 pair of boxes of color C so that they are placed adjacent to each other, then you can't place this box C so that you can activate the explosion. So you can't make a pair of make a triplet of same color now, so that they are adjacent to each other, and then the explosion will start. So that's the first thing we need to find. Now let's say you have, this is the boxes of color C. This is the adjacent 2 elements of the color C. So you have the choices that you can either choose the explosion from here. So if you choose the explosion from here, what will happen? It will explode, and after that some elements in this range. So basically let's see the constant. What is the constant we have given? So 10 to the power 3. So we can start our explain. So clearly we can see one thing, that let's say this is the boxes of color C, 2 boxes of color C which are just adjacent to each other. Let's say this is the case, you have color C, and you have 1 boxes of color C which you can insert between these 2 boxes. So your explosion can start from here. So if your explosion is going to start from here, what will happen? If your explosion is going to start from here, what will happen? You want to find the maximum number of explosion which can happen. So 2 boxes will explode at this place, and after that these 2 will share their edge. So if here you again found some number of boxes having same color, then it will also got busted, and then you will move like that. So you have 2 pointer, and this 2 pointer is going to move like that. So you will explode these 2 boxes, and these 2 indices got attached of the boxes. So this is the new boxes we have. Let's put the boxes and attach it here. So this is the new boxes here. So you can use it, you can calculate, if the explosion starts from here, you can calculate the number of explodes in order of n, and the explosion can start at most from n places. Now there are n indices. For each indices, the number of explosion you are going to find in order of n. So the total complexity of the solution is going to be order of n into n, that is n square, and that solution is acceptable. So we can write our solution like that. So let's have a for loop. For int I equal to 0. So you can see in this cases what is the number of answer. So number of explosion is going to be 2 to 4 to 6. 6 explosion will happen. So I equal to 0, I less than capital N, I plus plus, This is the case we have, not capital N minus 1. Okay, so check if if COL, call of the color of the ith box is equal to call of I plus 1 box, and call of I, color of ith box is equal to C. If this is the case, then what will happen? Very simple, very simple. If this is the case, very simple thing is going to happen here, that your explosion will start from here. So you already know that there is only two boxes of the same color which will be adjacent to each other. So call and call I plus 1 is adjacent to each other. So let's find what is the, you want to find the maximum number of explosion which can happen. So let's say the maximum number of explosion I am going to store in a integer variable answer. So I want to maximize that number of explosion. So answer equal to maximum of answer comma number of explosion happen if the explosion start from I and I plus 1. So these two indices will go exploded I and I plus 1, and then after that you have a starting index of array is 0, and you have exploded till you have remained 0 to I minus 1. Okay, and I plus 2 to capital N minus 1. This is the remaining part of your given boxes. So, and you want to calculate that if our new box is starts from 0, and in that our new boxes, what is our new boxes? It is starting from 0, ending at I minus 1, again starting from I plus 2 and N minus 1. So these are two boxes now, 0 to I minus 1, I plus 2 to N minus 1, but these two boxes are attached now. So I minus 1 is the neighbor of I plus 2. So in that case you want to find the maximum number of explosion, more explosion which can happen. So I am expecting from this function that it is going to return me that value. So if it is going to return me that value, so I will add that value in 2, and that is going to be the number of explosion when the explosion start from I and I plus 1. That's it. So after doing all these things, what I will do, I will simply return answer. Now I want to implement this function f. So this function f is going to return me the number of explosion which can happen, and our box is start from I, and I am at I1, and again starting from I2 and ending at J, let's say J. So I am putting it J, and then we have a color array int call. That's it we have. So what we can do, so let's say the color of the box present at I minus 1 index is, let's say, COL. So first thing is, if okay, so color is, let's say, int c equal to call of I1, call of I1 I2. Basically let's say int c equal to -1. Okay, if I1 is greater than equal to I, if this is the case, then in left side we have some remained number of boxes. So the color will be nothing but call of I1. Very simple. And if this is not the case, check that if I2 is greater than, less than equal to J, less than equal to J, if I2 is less than equal to J, else if I2 is less than equal to J, if this is the case, then in right side also we have some number of boxes. So C equal to call of I, call of I. Very simple. I1, I2. Okay, let's say after running these two statements, if the color is already -1, C is equal to -1, then in that case you can't blast some number of boxes. So return 0. In that case return 0. Okay, so let's say you have int I11. So basically let's say some number of boxes having color equal to COL I1 in the left side. And from starting from I1, let's say you have this boxes I1, you have this index I1, and you know that, let's say this is the index I11. So from I to I11 the color of the boxes are same, let's say. And in the similar manner, from I2 to I22, let's say the color of the boxes is same, these all colors are same, then it all will get busted. In that case, this all is going to burst in that case. And after bursting, you will the remaining part of the array will be I to I11 minus 1 and I2 2 plus 1 to j. This is going to be your answer. So I am implementing like that. Let's say you have an interval, equal to 0. So I am going to store in this interval is the number of boxes you have eliminated whose color is call of I1. So and I have some indices I11, I22. These are the two indices I have, let's say. So in that case, what will I am going to return? So val number of boxes got busted and how many boxes will further got busted is will be from the remaining part, and remaining part will start from I to I11 minus 1 and I22 plus 1 comma j. That's it going to be, and we have a color. So that's what I'm going to return. Now our whole effort is to calculate this I11. So let's say I11 is equal to I1, let's say. Okay. Oh, so what I will do, while call of I11, while I11 is greater than equal to 0, greater than 0, greater than 0. Okay. And what you will do, if color of call of I11 is equal to call of I1, in that case decrement I11 minus. Okay, very simple. So okay, very simple. And if this is not the case, if else is the case, then break from there. Very simple. And same goes for this second else if case. In else if case, we want to calculate I22. Let's say I22 is equal to I2. So while I22 is less than j, very simple. While I22 is less than j, okay. While I22 is less than j, if call of I22 is equal to call of I2, so I22 plus else case में break. Okay, very simple. So this is going to be the solution of this question. Okay, very simple. We have these things. Okay, so let's have we have a base case that I1 is less than I and j is greater than I2 is greater than j, I2 is greater than j. In that case, return 0. This is going to be the base case. So basically that recursion is order of n. Your output is 2, but it should give 6. So what we can do, 2 will broke. This is going to be the case. Then I minus 1, I plus 2. Very simple. We have done very correctly. I11 minus 1, I22 plus 1. C ought. Let's have a case. C ought I1 acha, we haven't incremented the val na. So val, each time you are in this loop, you have to, you are incrementing this value. So basically val, so basically val plus plus. Okay, val plus plus, same goes for this place also, val plus plus, val plus plus. Okay, so in that case 3 is going to be your answer, not it's, so you have to basically increment it inside the loop. The number of times the loop is running, that is the number of times you are uh, getting. Okay, so now it will work. So it's basically val plus plus, val plus plus, I1 is greater than equal to 0, color of I11 is equal to color of I1, I11 minus minus, val plus plus, C ought I1 I2, C ought I1 I2, C ought I1 I2 in del. One four, what is this, 1 4, that's correct. Then after minus 1 and 6296433, what is this, I22 is equal to I2, I22 is less than J, val plus plus, if I22 plus 1. So the contrast has been ended. Let's submit the code first. So basically this is the problem statement. We have I2 I11, what is C ought I11, I2 is less than equal to J, C is equal to all of I2, I22 is equal to I2, while I22 is less than J, val plus plus. Okay, let's say I11 equal to I1 and I22 is equal to I2. Now do the things we are talking about. Minus 5, 0 1 2 3 4 5, कितना बार लूप चला होगा, 4 से एक और चला होगा. तो यहाँ पर वैल इक्वल टू 2 कर देते हैं, ठीक है. So it's giving the number of times it got incremented. Oh, let's leave all that. Absolute value of I11 minus I1 plus 1 plus absolute value of I22 minus I2 plus 1. So you can see the clearly the same logic works, but the little different that I written here else if now, so it will, you have to add both side of element now. That's why it was giving error. Now it's correct. It was a silly mistake. So I was a little fast. That's why I have done some silly mistakes. So basically, again it is giving error. Its correct output is 2. It's giving 5. So if val is less than 3, so you are going to return 0. So you have 3. You have how many places where you can start your 3? Here, here, here. Okay. If color of I1 is not equal to, we have to write one case. If so, if this is the case we have, if let's say one of the side got broken, so if I1 is less than I, yeah, I2 is greater than J, in that case return 0. Or there is one more case, if color of I1 is not equal to color of I2, in that case also we have to return 0. So that's what this was the case. That's why it is giving an error. So let's submit it. So it's giving 5. Its correct output is 8. Basically 2, 2 3 5 3 8. You are starting from here. Basically I1 is less than I, I2 is greater than J. So you can see the logic I was talking about got implemented and it gets submitted. So that time I was very quick because the time was very less. That's why I have some error and I can't submit that code that time, but it was finally the same logic, the same code. You can say that time I was doing some error because of to be very quick. So we can move to our next question and try to solve that question as quickly as possible so that we can move to the next question we have. So don't be so fast. So this is the third question I have. So basically given array A of n integers. So you are given an array A of n integers and an integer x. The task is to count all the triplet I, j, k such that I, j, k ranging I, j and k will vary from 1 to n, which satisfy the below condition: j minus I. Okay, so j minus I is greater than equal to x and x is less than equal to k minus j. Okay, so basically this k minus j is the number of element from j plus 1 to k. That's it. Now 5 minus 3 is basically 2, so 4 5. So k minus j is nothing but number of elements ranging from j plus 1 to k. So x will be less than equal to k minus j. Okay, so you have given an array A of n integers and an integer x, और आपको एक integer x भी दिया गया. The task is to count all the triplet I, j, k such that I, j, k is the indices of the element of the array, and the element of the array is ranging from 1 to n, and again x is less than j minus I. So you have given an integer x. Basically you have given an integer x and they have also given you an array A, vector A of length n, and they are telling you to find the number of triplet I, j, k. These triplets are actually the indices of the given array A. So we have let's say three set of indices of given array. In given array a, I, j, k. So I is less than equal to j is less than equal to k. Okay, very good. So they are telling that the number of elements ranging between I to j minus 1 is x. So x should be less than, so x is the given integer, so x should be less than equal to number of element in range I to j minus 1. Okay, so x should be less than equal to j minus I, and after that they have one more bounded on the x, so that x is less than equal to k minus j. So x is also less than equal to number of element in range I j k, j plus 1 to k. So x should be less than the both of things. So let's say your j is the mid element and you want to pick two indices I and j such that number of elements in the left of j till I. So basically your indices are arranged in this manner now. This is I, this is j minus 1, this is your middle element j, and this is your next element after middle is j plus 1, and this is your last element, that is nth element. So if you call this part the left part of j, and this if you are going to call this part the right part of j, and I, j, k are the indices of the given array. So if you call this the left part, if j is the mid, and if j is the element you have picked, and I is an index you have picked, and k is an index you have picked, so I to j minus 1 you can call it a left part, and similar manner j plus 1 to k you can call it right part. So this is basically we have, you can say the left part, and this is basically you can say the right part. So left and right is nothing but the number of count of indices in the range I to j minus 1 and the number of count of indices in the range j plus 1 to k. And they have told you one more thing, j minus I. Okay, so they have told you one more thing, that you have given an integer x should be less than equal to I, and left x should be less than equal to left, and x should be less than equal to right. These two conditions should be satisfied. These two condition should be satisfied. ये दोनों condition satisfy होना चाहिए. अच्छा, ठीक है, और कोई? And they are also telling you one more thing, that I, j, k are odd. I, j और k सारा का सारा odd होना चाहिए. So basically let's say you have picked an indices j, so x should be less than equal to left. X should be less than equal to left. So in this way you can bound that your I can vary in the range, in this range your I is going to vary. So you can bound the value of I. If you, let's say you want to find number of triplet for a particular j, then what you will do? If you want to find the number of triplet in a particular j, for a particular j you want to find the triplet. So if I am telling you that, let's say you have picked a indices j, okay, and so the number of element in this range from j minus j to, in this range I to j minus 1 should be greater than equal to x, should be greater than equal to x, because x is less than I minus j minus I na. So let's say, so your I will vary from some x, your I can vary from, for a particular j, your I can lie in the region, this region you can have. In a similar manner, your k will vary in the region like this, in the region 2. So if you call this region 1 and if you call this region 2, so you want to find the number of triplets such that j is odd, huh? And j is the element present at indices j is odd, element present at indices k is odd, okay, and then element present uh, in the range in at indices I is also odd. So if you once find the region in which your I can lie and the region in which your k can lie for a particular j, then you can find number of odd in this region 1. So if let's say the number of odd number in this region 1 is O1 and the number of odd numbers in this region is O2, then what can happen? Okay, so then what can happen? Very simple, very simple. You can, for every I in the region O1, you can pick a k in the region O2. So the number of possible I in O1 is, region O1 is O1, in region 1 is O1, and in region 2 is O2. So O1 into O2 is the number of triplets if you fix this j. So, and you can basically count the number of odd in this region and you can count the number of odd in this region very simply by using the prefix and suffix array. Then you can iterate over the array, and if you found an index j such that the element present at this index is odd, if the element present at this index is odd, then you will find the number of O1 and O2 and then you will multiply O1 into O2. And a case can happen that, a case will happen that if let's say you have given an integer, you have given the x value is equal to 0, in that case what will happen? You can consider this number 3 times. So your triplet can be like this now, j, j and j. It is also a valid triplet you have. So this, in that case we will increment the count by 1 and again we will calculate for the region j minus 1 and till the range and j plus 1 till the range O1 and O2 in the given range, and then multiply those two. So in this way our solution is going to be for this question. So how we can calculate these things? So basically, first let's say you want to find the prefix array and suffix array. So basically we can only do the things using prefix array. So vector of int, I am making only prefix array, vector of int pref, and its size will be n comma 0. Let's iterate our vector a for int I equal to 0, I less than capital A dot size and I plus plus. Very simple. And then you can do pref of I equal to a of I modulo 2. If a is going to be a element at I index is going to be odd, then automatically our pref will get filled with 1. So if I find the prefix sum of this pref array, if I am going to find this prefix sum of this pref array we have, so we can do like this. So basically pref of I is equal to nothing but pref of I plus is equal to nothing but pref of I minus 1. That's the simple thing which I am going to do. Now I have the prefix array, so I can easily compute the number of odd in the given range j minus 1, let's say in a range 0 to x, and similarly in a range j to n. That's it. So let's iterate over the j for int I equal to 0, I less than capital N and I plus plus. Very simply I am iterating over the array. Now this is going to be, let's call it j, let's call it j. So basically you are iterating over each element. Now what we can do the next is, basically you want to find the region in which your x is going to lie, your I is going to lie. So your I is going to lie in the region, let's say 0 to I1. Okay, and in the similar manner your j is going to lie in the region, your k is going to lie in a region k1 to capital N minus 1. Very simply. Now let's say if I have talked about one more cases, that if x is equal to 0, in that case your I1 is going to be j minus 1 and your I2 is going to be j plus 1. Your I1 is going to be j minus 1, your I2 is going to be j plus 1. So your int I1 is going to be, in this case, is going to be I minus 1, I minus 1 nahi, j minus 1. So 0 to I1 index, your I can vary, can lie. So in the similar manner your k1 is going to be j plus 1. Very simple. Okay, so you have I1 and k1. Very simple, you have I1 and k1. So you want to find the number of odd, let's say O1 in the region 0 to I1, in the 0 to I1. So let's initialize the number of element in the region 0 to I1 which is odd by a value 0, and in the similar manner for region 2 I am initializing the value of O2 by 0. Let's say at the moment this is going to be the number of odd and even we have. Okay, so if I1 is greater than equal to 0, then there is some number of odd integers can be in the range 0 to I1, and that is going to be nothing but pref of I1. Very simple. In the similar manner, if k1 is less than equal to n minus 1, okay, in that case your number of elements in the range O2 which is going to be odd is nothing but ref of I2, not ref of n minus 1. Okay, ref of capital N minus 1. Very simple. And if k1 minus 1 is greater than equal to 0, O2 minus equal to ref of k1 minus 1. Very simple. In this manner we can write the code, and we have calculated O1 and O2. So let's say you have a global variable long answer. So in that variable you basically want to store the number of triplets. So let's make it long. So long, let's make it long. So what we can do, very simple, we can do answer plus equal to O1 into O2, very simple. One more thing I am talking about, that if x is equal to 0, then x is equal to 0 and x is equal to 0, then one triplet will be j, which I haven't counted yet. So answer plus equal to 1. Very simple. So in the similar manner, if the number of this x is not going to 0, in that case, so you are basically telling that your j minus I, okay, so j minus I is greater than equal to x. Very simple. So your I is going to be in the region j minus x is greater than equal to I. So I should be less than equal to j minus x. So your in this case I1 is going to be equal to j minus x. So this is going to be your first region, and in the similar manner k minus j is greater than equal to x. So k will vary in the region, k should be greater than equal to j plus x. So this is going to be I2, I2 nahi k1, this is going to be k1. So I1 and this is k1. So basically we have I1 and k1. So let's talk what is the value of I1 and k1 in this case. So similarly copy all these things, control C, control V. So your I1 is going to be j minus x, very simple. J minus x is going to be your I1, and in the similar manner j plus x is going to be k1. Okay, very simple. You can do the things in this manner, very simple, and the rest of the things will remain same. Okay, so answer plus equal to 1. I have to remove this answer plus equal to 1, but the counting will happen only when your element present at index j in array A is odd, modulo 2 is not equal to 0. In that case only you can run these things. So I am putting these two if else conditions in another if condition, which is verifying that the element present at index j is actually an odd number or not. So if it is odd, these are the things we are going to, these are the steps we are going to do, and after that we will simply return answer. That's the main target we have. Okay, so let's see how the things is working. So let's see. So I think it should work. It may be the case we have some error. X was not declared in this scope. So X is basically a capital letter. So make it a small. J plus X. X was not declared in this scope. So here I have written capital X. So let's make it a small x now. Your output is -5. How it will be possible, bro? How the things are going to be counted? Ref of n minus 1. Ref of k1 minus 1. Okay. I have to check that what is the error we have. Why it is giving -5? Prefix array, it was calculating correctly, no problem. Now inside this loop there is some problem. A modulo j is not equal to 0, that means it is odd. So if x equal to 0, so if I1 is greater than equal to 0, pref of I1. Okay, very simple. In that manner k1 is less than equal to n minus 1, so 2 equal to pref of n minus 1. Okay, so this is a step we should do. Pref of n minus 1. It's working. So basically if this if condition will run, then O2 will take argument now, and if it will take argument, then we will decrease that value. So you can simply know the logic. So let's submit the code. Let's see it's working or not. So here we have one more error. Answer plus is equal to 1. So let's submit it. So this is the case. You can see we have done with all the problem statement. So thank you.